Welcome back, pre-calculus. I'm here in another video on Unit 1, Graphs of Polynomial Functions. And in this video, we're going to talk about how you can find the zeros of a polynomial function by factoring. So suppose I'm given a function. What a nice gift. We all love to get functions. I'm given a function f of x. The x values that make f of x equal 0 are called the zeros, and they're very important. They're very important in this course. We're going to talk a lot about zeros of functions. They also tell us where this graph would cross the x-axis. So they also tell us where this function, f of x, crosses the x-axis. So they're important in graphing the x-axis. And when we're talking about them in that way, when we're talking about them as points on the x-axis, we also call them x-intercepts. X-intercepts. So let me give you an example so you can know what this is, what we're talking about. We're talking about a zero. So here's a little example for you. I know that x equals to -1 is a zero of the function f of x equals x cubed plus 1. And I know that because if I take -1 and I plug it into my function, everywhere that I see an x value, here's what I get. I get f of -1 is equal to -1 cubed plus 1. And if I simplify that, -1 cubed is -1 plus 1. That gives me 0. So that's why you call it a zero, is because when I plugged it in here, I got out the answer of 0. If I were talking about this as an x-intercept, I might tell you the point -1 comma 0 is an x-intercept. And I might tell you x equals -1 is a 0. So these are two different ways of talking about this, calling it either an x-intercept or calling it a 0. It just depends on context, what you want to say. If we're talking about graphing, we're going to want to talk about x-intercepts. If we're talking just about solving equations, we usually will say is a 0. Just a little bit of math grammar there for you. So one method that you can use to find zeros of polynomial functions is by factoring. So one method for finding zeros is factoring. And I'll show you just a quick example of that. There are also a link in the description to this video. I have some other videos on factoring that I made for an algebra class last year that you can use to review. If you are feeling like, oh no, I forgot a lot about factoring, you can review that. You can also look at the OpenStax textbooks for algebra, and there's a nice review in there if you feel like you're missing something. So let's look at this example. This example also might help you enough just to kickstart your memory. So I'm going to say find the x-intercepts of f of x is equal to x to the 6th minus 3x to the 4th plus 2x squared. And we're going to do that by factoring. So when I'm factoring, there's really just two things I'm going to do. The first thing I'm going to do is I'm going to look for a GCF to factor, And then the second thing I'm going to do is factor any composite by and trinomials. That's very math lingo heavy. I'm going to go into that and explain what I mean by factoring composite by and trinomials. So for step 2, when something is composite, this is a fancy word that just means you can factor it. So what I'm saying here is that you look for things that you can factor, and then you factor them. Composite means you can factor it. And bi and trinomials here, I'll show you in our example. What's a binomial? What's a trinomial? But these are really the only 2 steps we're going to do. And then I would say your step 2A is you just repeat step 2 until you can go no further. And then you have step 3, which is you want to set each factor that you have equal to 0 and solve. And that's going to give you your x-intercepts here. So let's take a look at this example. We have x to the 6th minus 3x to the 4th plus 2x squared. And so the first thing I'm going to do is my step 1. I'm looking for a GCF to factor. And I see here that I have an x to the 6th, an x to the 4th, and an x squared. So because x squared, that's my smallest degree on each of these terms, I know that I have an x squared in common. And in coefficients, there's an invisible 1 here, and then I have this coefficient of -3 and -2. So there's nothing in common when it comes to the coefficients, except for 1. Isn't that important? But there is that x squared. So I'm going to factor out the x squared. That is our GCF here. And what remains is x to the 4th minus 3x squared minus 2. If you doubt this step, multiply it back in. Distribute the factor back in, and you'll see that this brings us back to our original statement, which means that this is another way of writing it. We're just factoring. So that was step 1. And then now what I'm doing is I'm working on step 2. So I'm looking for any possible composite bi and trinomials that I might be able to factor. This is fancy math lingo for looking for things I can factor. And I see this here. This is a trinomial. This is a trinomial because I have 3 terms. 1, 2, 3 different terms. And so I think I can factor that. So we have our x squared, and then this is going to factor like so. I see that I want my last 2 terms to multiply to be -2. Oh, I'm sorry. I wrote -2, but this example is supposed to be +2. Can't decide if I wrote it correctly up here. I did. Oh, look at that. I wrote +2, and then down here I wrote -2, which wouldn't actually have worked. Eee! I'm sorry for that, you guys. All right. I hope you're caught up with me now. You caught that little mistake of mine as I made it. And you can see we're looking for factors that multiply to be +2, but that add up to give me -3. So I know that -2 and -1, when I multiply those 2 together, I have a negative times a negative, and that'll give me +2. And when I add them together, -1 and -2, I get -3. So that's how I'm making that choice for those terms there. And then here I see my x to the 4th power. And I know when I multiply 2 things together to get something to the 4th power, it has to be an x squared. X squared. And so that's how I factored this trinomial here. That's how I factored it. And again, if you're not sure, you can test me. You can FOIL this out. You can distribute here. And you'll see that if you distribute these two binomial expressions, you'll get back to the trinomial we were just working with. And now I'm at step 2a, right? I factored one factorable thing, but that doesn't mean I'm necessarily completely finished. I need to look and see if there's anything else I can factor. And I do, in fact, see something else I can factor. This here is something called a difference of squares, which you may remember from your algebra course. It's called a difference of squares because there's a subtraction symbol here, and I have a perfect square here and here. So there's a formula and a way of factoring that tells me that every difference of squares factors like so. Well, not every one factors exactly like this, but they all follow the same pattern. So I'm following a pattern that I remember from my algebra course. If you forgot it, that's okay. You can take a look at the video that I have on difference of squares, or you can review it in the textbook, or you can look up another video, or you can ask a friend, or you can ask me in class. Don't worry. If you don't remember, we will catch you up. Okay, so now I think I'm done. I don't see anything else I can factor. So now that I'm finished factoring, what I'm going to do is I'm going to set each one of these linear factors equal to 0 and solve. So each one of these I'm going to set equal to 0. I'm going to say x squared is equal to 0. And then I'll take the square root of each side. And I'll get x is equal to 0. And that'll be one of my answers. And I'll take x minus 1, and I'll set that equal to 0. And I'll add 1 to each side and solve this little equation and get x is equal to 1. I'll take x plus 1 and set it equal to 0. And then I subtract 1 from each side of this little equation, and I get x is equal to negative 1. I'll set x squared minus 2 equal to 0, and I'll solve this little equation as well. So I see, do not be frightened by seeing something raised to the second power. My first move is going to be to add 2 to each side, and that's going to isolate my square root here. And my second move will be to take the square root. And so I'll have x is equal to plus or minus the square root of 2. So now I have all of my beautiful zeros for this equation. But what the problem asked for was x-intercepts. So I'm going to write these in the following format. I'm going to change them into x-intercepts. Ready? So I'll have the x-intercept 0, 0, the x-intercept 1, 0, the x-intercept negative 1, 0, the x-intercept square root of 2, 0, and the x-intercept negative square root of 2, 0. These are all answers. And you might wonder, Sarah, where did you get this? Where did you get this? Fear not. This x equals 0 gives me the x coordinate of 0. And then this piece here, this symbolizes the fact that our y value will be equal to 0 when we plug in the x value. And then so where x is equal to 1 and negative 1, that gave me these x-intercepts. And where x was equal to plus or minus the square root of 2, that gave me these x-intercepts. And that's how I got that answer in that particular format. I hope this video was helpful. I know for some of you, I'm going into too much detail and going too slow. And for some of you, I'm not going into enough detail and I'm going too fast. So here's my proposed solution for that. Ask questions in class. Please. I really do look forward to hearing from you and seeing what else I should have included in this video to help you. So stay safe, and I will see you in the next one. I hope you're having a good day wherever you are, whatever you're doing. You got this, guys. Talk to you soon.